This lesson is part of a series of training videos where we will look at a specific product in a specific installation, comparing our installation instructions and good practice with actual conditions on a job site. The primary goal is to help you become more familiar with our products, enabling you to tell if they have been installed correctly and if they're doing what they're supposed to be doing. Along the way, we'll also discuss what's important for when we need to determine if something is close enough, what's dangerous for when we need to bring something to the contractor's immediate attention, and why our products are used the way they're used. These videos will assume you're already somewhat familiar with the products being discussed. If you haven't already done so, please take some time to watch our other product training videos that go into detail on our various products, features, and components. Vibro-Acoustics creates noise control solutions for the HVAC industry, addressing both airborne and structure-borne transmission paths. Our vibration isolation products help mitigate equipment vibrations that could cause noise problems in buildings. In this lesson, we will look at CSR isolators installed on a water-cooled chiller. In mid-2015, Vibro-Acoustics secured a vibration isolation order for a project in downtown Toronto called the Axiom Condominiums with multiple pieces of equipment and piping. The mechanical penthouse of the East Tower included various pieces of equipment, including a water-cooled chiller located here in this room. As required by the project documents and as recommended by the acoustical consultant, this 240-ton chiller is supported by restrained spring isolators, specifically 2-inch deflection CSR isolators, complete with neoprene pads under the base plates. They were selected for each corner of the equipment based on the weight shown in the chiller submittal, which is about 14,500 pounds. This is the submittal we provided for some of the equipment on this project, complete with summary page and data sheets and installation instructions. Note that the most recent versions of these data sheets and installation instructions are available on our website. They are often subject to changes and improvements, so always refer to the latest for the most up-to-date information. Let's take a closer look at the datasheet and installation instructions for this isolator, and focus on some key things we'll want to look for when we visit the job site. In a previous training video, we went over the various parts of a CSR isolator, explaining their uses and functions. This graphic here is meant to help familiarize the contractor with the various components, their names and locations, which are referred to in the notes and instructions. It shows overall dimensions of the product as well as dimensions of holes for attaching the isolator to structure and to the equipment if they choose to bolt rather than weld. It also shows the expected working clearance between the equipment support plate and the hold-down plate, 3/8 of an inch. This will be something we'll want to look for at the job site. Also on the datasheet are some notes that need to be considered. They provide descriptions of the materials used and the function and purpose of different components. A few of these are things we'll want to look for at the job site. This note says, top plate and restraining bolts are designed to be out of contact with housing during normal operation. So combined with the working clearance shown in the graphic above, we'll want to make sure those components are not in contact. Neoprene grommets are incorporated to minimize short-circuiting of restraining bolts. We'll want to take a look at those and see that they're doing their job. If less than 80% of the top plate is covered by the supported equipment, use an additional plate, same thickness as the isolator's equipment support plate, on top of the isolator. This note is clarified on the installation instructions page, which we'll look at next, but before we leave this page, one more very important thing is the plan view of mount locations. This graphic shows which isolator goes where on the equipment. Many times, the center of gravity of the equipment is not in the geometric center and the corner weights are significantly different, requiring the use of different springs to match the loads and keep a similar deflection. In this case, all 4 corner weights are close enough to the same that the same isolator has been selected for each support, CSR 2A-H4100, which, according to the table, uses a blue outer spring and black inner spring. We can check that the correct isolators have been used by checking their spring colors on site. In fact, the very first instruction on the installation instructions page says to properly locate each isolator using the model and spring colors as identification. The instructions then go on to explain the process for installing the isolators and then the equipment onto those isolators. We won't cover that part in detail here, however we do want to cover the attachments that are required. Instruction 3 says to attach the equipment to the support plate, for example by welding. The datasheet gave the size and location of bolt holes in the top plate should they choose to bolt, and the graphic here gives guidance on welding, showing a field weld of 1/8 inch leg size, 2 inches long every 3 inches on one side. The image here better explains the 80% rule, where an extra top plate is required to add additional stiffness and prevent sagging during installation. Though not explicitly stated here, it would be expected that the equipment or steel beam would be welded to the extra top plate, and it in turn would be welded to the isolator top plate. The next step shows that the contractor needs to move the hold-down nut down to touch the head of the limit bolt. This will allow the equipment to float. This step is often missed, so we'll want to check that this has been done. This step shows the contractor how to adjust the isolators to transfer load to the springs. Note the adjustment pattern plan view on the right, which helps ensure the load is evenly distributed among the different isolators. A common site problem is springs that have been over-adjusted because this pattern and process was not followed properly. This instruction says to remove the spacers once the equipment is floating on the springs. Another common issue on job sites is that the spacers have not been removed, often because the springs were never adjusted. We'll want to see that the isolators are adjusted and the spacers removed. Now that we've looked at the submittal datasheet and installation instructions, we're ready to go look at the installation on the job site. We'll start at the entrance into the room. You can see the chiller mounted on isolators on a housekeeping pad, and you can hear that the chiller is running. The primary sound source is the centrifugal compressor. We'll walk past the condenser shell of the chiller to the back corner and take a look at the isolation back there. You can see that they're using flexible connectors for any pipes attached to the chiller. We'll talk about those in another video. It's very important to control structure-borne noise by eliminating rigid connections. Here is one of the CSR isolators. We can see that it appears to be the correct isolator. There is a blue spring on the outside, and though we can't see it in the video, a black spring on the inside. It appears to be installed relatively correctly, directly under the equipment foot and secured to the floor and to the equipment. The spacers have been removed, and the hold-down nut has been lowered to the hold-down bolt head. The washer here can be moved so it's not too tight. Placing my hand in the gap, I can feel that the top plate is vibrating slightly. I can also feel vibrations in the spring coils, which importantly are not fully compressed. A quick check that the nuts securing the isolators to the floor are tight. We'll go look at the next isolator on the evaporator side. This isolator also appears to be the correct isolator and installed relatively correctly. We can see that there is a gap between the top plate and hold-down plate, and the nut has been lowered to meet the bolt head. Interestingly, one of the nuts securing the isolator to the floor was not tightened, so I made it at least finger tight. You can see here one of the spacers that was mentioned in the datasheet and instructions. It would have been originally located between the top plate and the hold-down plate, like this. But notice here how much extra space there is. The CSR installation instructions say to remove the spacers once the top plate just lifts off. It appears the contractor here decided to go a bit further. A quick look at the leveling bolt and compression cup shows markings on the nut, evidence of adjusting the load onto the spring. In general, it seems to be okay. Taking a look at the connection to the top plate, we find a couple of fillet welds at each corner, meeting the requirements shown on our installation instructions page. So what do you think? Do you see anything we need to have the contractor fix or correct? Or was it close enough? Was there anything dangerous? And did it appear to you to be working? Let's talk about the first isolator we looked at and consider the items mentioned when we reviewed the datasheet and installation instructions. Is it the right isolator in the right place? Yes, we already checked that. Have the spacers been removed and is the equipment floating? Yes, the equipment is being supported by the spring and the top plate is not touching the side stanchions. Is the working clearance about 3/8 of an inch? It's actually more than 3/8 of an inch. Are the springs adjusted? Yes, we can see that the springs have been compressed. The unloaded free height of these particular springs is 5.5 inches. These have been adjusted since they are shorter. In some cases, an acoustical consultant will want to measure this static deflection to check for compliance with a specification. The greater the deflection, the more frequencies will be isolated. It is also important to note that the springs are not fully compressed. If the spring coils were touching each other, that would mean that there was too much weight placed on the isolator, a problem that can be caused by various things. Depending on what the other springs look like, the solution could be to readjust the isolators or swap out the springs for stronger ones.
Are the grommets in place and are hold-down bolts properly set? The grommets are in place and the hold-down nuts are touching the hold-down bolt heads, but the washer is in contact with the lower part of the grommet and pushing it into the hold-down plate. This could be a problem that may create a vibration isolation short circuit path where the vibrations from the equipment go through the side stanchions instead of into the spring. But since I was able to move the washer, it's not pressing upwards too tightly and there's no metal-to-metal contact. This one goes on the maybe list, in that we maybe will ask the contractor to fix it. In order to fix this, they would need to lower the equipment slightly by adjusting the leveling bolts to unload the springs. Lowering equipment after all the pipes have been attached may be difficult since there are multiple connections to keep lined up. So typically, there's no need to ask for corrections if it's not dangerous and if it's not creating any problems. There is nothing dangerous about this. In fact, this is exactly what a properly adjusted isolator would look like when the equipment is drained for service. It's why we use this kind of isolator in the first place. It limits the vertical movement of the equipment to minimize stresses on the pipe connections. So it's not dangerous, and as far as we know, it's also not creating any problems, since at the time of our site visit, the equipment was running, but there were no noise or vibration complaints. Is the equipment support covering less than 80% of the top plate? Well, this one is close. I didn't measure it because the rule of thumb is that the equipment support should be at least as wide as the opening, or distance between the side stanchions, and this one is. But more importantly, the top plate is flat and does not appear to have been overloaded and bent. Even if the equipment support were smaller than 80% of the top plate, as long as the top plate was not deformed and nothing else damaged, then it would be okay. There could be a problem if too heavy a load is placed on too small an area on the top plate, which could cause it to deform during installation before the springs are adjusted. This could lead to the hold-down bolts being angled and creating short circuits with the hold-down plates. Is the equipment connected to the isolator? Yes, there are welds that are close enough to 2 inches long and every 3 inches, as shown on the installation instructions page. Is the isolator connected to the floor? Yes. Though our data sheets and installation instructions do not require it to be attached, it is good installation practice to secure isolator mounts to the floor. This project does not have any seismic requirements. There is no need to provide lateral restraint for this chiller, so the housings don't have to act as restraint to prevent sideways movement or overturning. However, the contractor here used what appears to be pieces of threaded rod pushed into holes drilled at angles, possibly after the chiller was placed on the isolators, and probably using an adhesive cement to anchor it in place. The nuts and washers don't sit flat since the rods are angled and, as we saw on the other isolator, were not adequately tightened down. If this project had seismic restraint requirements, these anchors would not have been acceptable. But since it's not a requirement and isn't causing a problem, we don't need to say anything to the contractor. So that wraps it up. My final conclusion on this site visit is that the isolators have been installed close enough to our installation requirements to be approved, with a caveat that should they experience any vibration or noise problems in the spaces below the chiller, they should adjust the working clearance and ensure the hold-down nuts and washers are not touching the hold-down plates. In this lesson, we've looked closely at the datasheet and installation instructions for a CSR isolator in the context of performing a site inspection where CSR isolators were used to support a water-cooled chiller. We discussed various items to look for during an inspection and assessed whether the product was installed in a manner that it could ensure it could do its job. I hope through this lesson you become more familiar with the CSR isolator and its use.